Okay, this one says the wooden box in the diagram is a rectangular prism and it is open at the top. We need to underscore that no matter what. That is a key. That is imperative. Open at the top. So that means the volume does not change. Whether it's open or closed, it doesn't change the volume. What changes is the area. And you can look here, they're dealing with area. So that means when you're dealing with area, you're going to deal with area of the 5 sides. I'm going to tell you that. So remember, we got the dimensions of the base are 3x and x, and then the height, it's y meter. They're telling me the total area, it's 147 square meters or meter square. They say show that y is given by that. All right. First, what I want to bring to your attention is the following. Is that you have this face, the one that is in front. This is the front, the red one. Then you've got another one at the back. They're the same, front and back, front and back. So those are the same. When you calculate them, it's going to be 3x times by the y, those ones. That is for the area. We're not done, but we're trying to get the total area. We know total area is 147. There it is given. So I need to take 3x times y, but I need to do that twice. We need to do that twice. So it's going to be 3x and then times y. The number must be doubled. We need to double that because there's 2 of those. Then plus, we've got another one that we need to consider. All right, the one that we need to consider is the one I'm also highlighting in red. That face, the one on the left, it takes x here and a y. It's x times y. So the one on the left is exactly the same as the one on the right. They're the same. So those two, left and right, left and right, those two are exactly the same. It's x times y, but we're going to have to double that. So it's going to be x, y, but we need to double that. All right, then we need to go add the other one. There must be another one that remains. The one that remains is right at the bottom. The bottom one. So that is the bottom there. Remember, the top there is nothing. So what I mean is, if I were to come here, the red, there's nothing. They told you it's open at the bottom. So you only use the bottom one, 3x times the x, that's all. You can't use the top. That's all, 3x times x. So that means we're gonna write 3x times the x. There we go. Everything is gone. All right. So now we wanna solve for y. So I'm gonna go a little bit faster. We got 147 here equals to, this one becomes 6xy, then plus 2 xy, then plus 3 x squared. Now let's add what looks common. What's in the red box? Like terms. So we've got 147 equals to, it's going to be 8 xy. It's going to be like that. So we're looking for 1 and then plus 3 x squared. So we need to transpose to the other side. So that means I'm going to have 147. I must subtract the 3 x squared equals to 8 x y. To get the y, I need to divide both sides by 8x. So y equals to what I'm going to render now. It's going to be 147 minus 3x squared divided by 8x. I believe that is exactly what they requested. They say show that y is given by that, which is exactly what they're looking for. There we go. Now they say calculate the value of x for which the volume of the box is maximum. So let's underscore here. The volume is maximum. So we're going to have to derive that. Derivative equals to 0. Alright, so now they say 4. Here's the key. Watch what the key say. They say where the volume. So you need the equation of the volume of the box. So volume is given by area of the base. 3x times x, which is 3x squared, area of the base. Then you must times that by the height. The y is the height. So the height is that equation we worked out here. That's what it is. So that means we need to open the bracket. We need to go 147, I believe, minus 3 x squared. Close the parentheses. We need to divide that by the 8x. Okay, that is the equation of the volume. There we go. All right, so now if we simplify that, I can tell that that x will cancel one of them. I'm just getting rid of the 2. So I've got 3x over 8. Or let's take 3x to multiply inside. So meaning I'm having 140. Now let's type that correctly. 147 times the 3. Alright, so it's gonna be 441, that is gonna be x minus, well, 3 times 3 is 9, so it's gonna be 9x cubed. Alright, everything over 8, so I will split that so that we are able to derive. I'll put over 8 here, and then I'll put here over the 8 over there. Alright, I don't know 144 in the 8 can go there. Does it go? while it remains as is. That is the equation of the volume. So let's box that one there. So that means from the box we need to derive now, because we're talking about maximum. They say calculate x. They didn't say calculate maximum volume. So once we get x, we're done. So we're gonna write like I did. I said for volume to be maximum. For volume maximum, I'm gonna write let first derivative of the volume equals to 0. So let's derive. I'm deriving that. So when you derive that, come on, we're left with 4, 4, 1 all over 8. And then minus. If you're gonna bring the 3 times 9 is 27. So you're gonna have negative 27 all over the 8, but it's gonna be x squared. You equate that to 0. Multiply everything by 8, so both sides, so you're left with 441 minus 27 x squared equals to 0. Transpose, you now have 27 x squared equals to 441. Divide by 27 both sides. So 441 divided by 27, I've got 49 over the 3. Take a square root, then you can now write x equals to, I'm going to say square root alpha, that and square root of the answer. I've got positive 4.04, or because it's a square root, it should be plus or minus, or x equals to negative 4.04. Now, let's go look. There is no way this can be negative because it's length. So we discard that one. This is invalid. The green is the only one in meters. That will be the answer for that one there. So we're done with this one here.